Hello, 2Ps. Today we are doing our fourth lesson in the geometry measurements unit, and we are doing cones. So cones are related to cylinders the same way that pyramids are related to prisms. So our learning goal for this session is to calculate the surface area and volume of cones using a variety of imperial and metric measurements. Okay, let's take a look at some cones. You are probably familiar with the shape. Here's some examples. Cones have a circular base, and then if we kind of unwrap the um, the side of it, it looks like a quarter of a pie. And I'm going to show you that on the next slide when we do the net. Okay, let's take a look at the equations for volume and surface area of cones. So here's a cone. The base is a circle. It has a radius of r, and the cone has a height of h. Okay, the volume equation, it's a third of the volume of a cylinder. So if you remember back to the pyramids lesson, that pyramids had the third of a volume of the associated prism. And if you watch the video that was in that lesson, it also did one with a cone and cylinder. So, so just like that relationship, the volume of a cone is the volume of a cylinder divided by 3. So our equation for the volume of a cone is pi r squared times h all divided by 3. Now the surface area, if we take a look at the net, and this is what a net looks like. So you can see there's a circle, that's our base, and then you can see that the side of it is kind of like a quarter of a pie. If you think of this as making a full circle, it's like a quarter of a circle. Okay, just to label some things, if you remember from when we did pyramids before, the distance from the base to the point is called the slant height, and the slant height is this distance here on our net. And then of course this circle has a radius of r. So the surface area is one circle plus the area of this slice. Now this actually is quite interesting to derive this, but you do not need to know that for this course. All you need to know is the equation that you're adding the circle and this area. The equation for the area of the circle is pi r squared, and the equation for this area is pi r times s, which is this distance. Okay? If you are interested in seeing how this part is derived, I can definitely find a video for you to share that with you, but it is not part of this course to learn how that is derived. Okay, let's do some examples. So let's see we have this cone. It has a radius of 13 centimeters and a height of 31 centimeters. So we're going to find the volume. So our volume equation is pi r squared times h divided by 3. And now we're going to put our numbers in for pi, r, and h. Oh, I guess I do pi on the next step. So r is 13, that's the radius. Remember, if you're told the diameter, don't forget to divide that by 2. And then the height is 31 centimeters. And we're going to divide that by 3. So now I put in 3.14 for pi. 13 squared is 169 times by 31 divided by 3. So now you're going to plug these numbers into your calculator. 3.14 times 169 times 31 divided by 3. And you should get 5,483 centimeters cubed. Remember, we always have a cubed on our measurement here if we're doing volume because we're involving three dimensions. Two dimensions here and another dimensions from H. Okay, let's take a look at the same cone, but let's find the surface area. So for this one, we're going to need to find that slant height, because if you remember, that slant height was in our surface area equation. So this is our surface area equation. Pi r squared is the area of the base, and then pi rs is the area of this side, you can think of it as. So we're not told what the slant height is. So if you're not told what it is, you can find it by using the Pythagorean theorem. Notice how this is a triangle. Okay, so Pythagorean theorem is c squared equals a squared plus b squared. Our s is the hypotenuse, so it goes in for c, and then our other two sides can go in for a and b. So s squared equals 13 squared plus 31 squared. So if we calculate these out, 13 squared is 169, 31 squared is 961, and if we add those together, it's 1,130. So don't forget the last step is to take the square root of both sides to get s, and the square root of 1,130 is about 33 centimeters. So now we can use our s is 33. So let's go on and do that part. So we have that labeled now, and now we can put in all of our values for r and s, as well as pi. So pi is 3.14, our radius is 13 centimeters, plus pi is 3.14, radius 13, and our slant height we found it was to be 33. Now we can calculate these out. And if you put these into your calculator, I like to do them separately. 13 squared is 169 times 3.14 is about 531. And if you multiply these three numbers together, you get 1,347. And now our last step is to add those two numbers together to get the total surface area of the cone. It's in centimeters, and don't forget the units are squared because we're dealing with two dimensions. We have two dimensions here with r and s, and two dimensions here with two r's. Okay, let's do another example just to go through this again. Let's say you have an ice cream cone. It has a diameter and a height, both equal to 10 centimeters. What is the volume? Okay, so here's our volume equation. We need the radius, but we're told the diameter. So don't forget that radius is the diameter divided by 2. So 10 divided by 2 gives us 5 centimeters for the radius. So now we can sub in our values. Pi is 3.14, our radius is 5 squared, and then our height is 10. So if you put these into your calculator, 3.14 times 25 times 10 divided by 3 gives us 261.8 centimeters cubed. So that's the volume. Something interesting here that I haven't mentioned before, but it's a good place to do it because I'm going to ask you a follow-up question is centimeters cubed is the same as milliliters. When we measure volume, especially when we're baking or cooking, we tend to use milliliters, don't we, in the metric system. So as just a note for you, 1 centimeter cubed is equal to 1 milliliter. So if we think about that with this question, let's say you get 2 scoops of ice cream. My favorite flavor is bubble gum. It's my absolute favorite, but it has to have the actual pieces of the bubble gum in it. You know what I mean? Anyway, it's hard to find these days, but I love it. So you get 2 scoops of ice cream, and each scoop is 125 milliliters. Now, let's say when you put it into the cone, you don't just put it in top, you try to get as much into the cone as possible. Um, so if you do that, will the cone be partially full or will it overflow? Will part of the ice cream come out of the top? Well, if 2 scoops of ice cream Sorry, one scoop of ice cream is 125 milliliters, while two of them is going to be 250. And you can see 250 milliliters will fit into the cone. That means this is less than how much the cone can hold. So it will only be partially full if you squeeze it all the way to the bottom. Let's take a look at finding how much cone would we be eating if we had this ice cream cone. So that means we want to find the surface area. So the surface area equation is this, but when you think of an ice cream cone, oh, actually, I'm going to do that next. So we need to find S, just like we did before, the slant height, so that we can find this part of the surface area. So again, we can use the Pythagorean theorem, c squared equals a squared plus b squared. In this case, S is our C, it's our hypotenuse, and the other two sides can go in for A and B. So S squared is 5 squared plus 10 squared, which is 25 plus 100, which is 125. And our final step is to take the square root of both sides. S is equal to about 11 centimeters. Okay, now that we have the slant height, we can find our surface area. So let's go to that. Now, here's our full surface area equation. But if you think about an ice cream cone, there's actually nothing here. It's only the side part, which means we can get rid of that part of the surface area equation. There's no cone on the top of this. So the surface area then is pi r s, which is 3.14 times 5, our radius, times 11, our slant height. We put those in, we get 173. And don't forget to put the units on it. So our units are centimeters and squared because we're dealing with surface area. Okay, of course, because it was a word problem, therefore I would eat 173 centimeters squared of cone. There you go. Okay, so I have posted practice sheets on Brightspace. There is a page for volume and a page for surface area, and both of them have the solutions included. So please go give those a try. Once you feel comfortable with those, you can go ahead and try the 5.4 quiz on Brightspace. So that is it for today. I will see you next time. We will be doing spheres. Okay, bye guys. Talk to you soon.